Hi everybody, today we are going to talk about probability. So the probability of an event happening, so P of E, is the number of favorable events. Favorable events meaning the event that you're trying to calculate for. For example, if you're trying to calculate the probability of rolling a 2, 2 would be the favorable event. It doesn't necessarily mean that it's better than anything else, it's just what we're calculating. And then in our denominator, we have the total possible number of events. So this is how we will go about finding probability. One thing to note is that probability will always be a number between and including 0 and 1. The reason is probability will essentially represent the percentage chance of something happening. So you can't have less than a 0% chance of something happening. That's not possible. And you can't have more than a 100% chance of something happening. So if you're ever doing a problem and you end up with a negative answer or something greater than 1, you know that it's wrong. So let's try these first two problems. Remember, we're going to do favorable outcomes over total number of outcomes. So you toss 2 coins. What is the probability that they are both heads? So let's list out what could possibly happen if you flip 2 coins. You could flip a head then a head then a tails then a head, or a tails then a tails. So looking at this, the probability of flipping a head then a head, well, there's only one favorable outcome. So our numerator is a 1. But I can see here that there are 4 possible outcomes. So the probability is 1 over 4. Now let's look at the second one. You draw 1 card randomly from a deck of 52 cards. What is the probability of drawing an ace? So I know that in a deck of cards, there are 4 aces. There's 4 of each type of card. So there are 4 favorable outcomes. But I also know that there are 52 total cards. So there's 52 possible outcomes. So then here you just have to simplify. It's 1 out of 13. So there's a 1 in 13 chance that you will pull an ace. All right, let's try an example like this. You toss a 6-sided dice. Or you toss 2 6-sided dice, sorry. What is the probability that the sum of the 2 dice is 7? So first thing we have to do is find all of the possible favorable outcomes. So I know that for my first die, I could roll a 1, 2, 3, 4, 5, and 6. So let's figure out all the ways that we could roll the second die to make a sum of 7. So I could roll a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4, 3, a 5, 2, or a 6, 1. So there are 6 favorable outcomes. Now to find the number of possible outcomes, we're going to use our counting principle. For each dice, so for the first die, there are 6 possible outcomes, and for the second die, there are 6 possible outcomes, which gives you a total of 36 possible outcomes when you're rolling 2 dice. So the probability that the sum is a 7 is 6 out of 36, which can be simplified to 1 out of 6. All right, now let's try a lottery game example. So this says that a person picks 6 numbers ranging from 1 to 44. If these 6 numbers match the 6 numbers drawn in any order, implying that this is a combination, not a permutation, the player wins. What is the probability of winning if a person buys 1 ticket? So first we need to figure out, well, how many favorable outcomes are there? Well, there's exactly 1 favorable outcome, and that's those exact 6 numbers. Any of the 6 numbers, it will not be a winning ticket. So now we have to figure out the total number of possible outcomes. And here's where we have to use the counting principles that we talked about yesterday. So here, since it said that it's in any order, that's implying it's a combination. So there's 44, choose 6. And this will give us a really, really large number for the total possible outcomes, which is 7,059,052. So the probability that you have a winning ticket is 1 over 7,059,052. So clearly your odds are not great. Okay, so now we're going to talk about the probability of the union of 2 events, meaning that if the events are A and B, that either A or B is occurring. So anytime you see or, you essentially know that you're going to be adding up or subtracting probabilities. So once again, anytime you see or, you're going to be adding up probabilities. So this is when you have two events that are in the same sample space. So there's two cases. The probability of A or B happening might be the probability of A plus the probability of B minus an overlap. So it's entirely possible that two different events have overlapping outcomes. For example, if you're working with a deck of cards, if you're trying to find the probability of pulling a 2 and pulling a spade, there are definitely cards, well, there's one card that is both a 2 and a spade. So the reason why we subtract this out is because this little sliver in the middle is being counted twice. It's being counted once for this circle and once for this circle. And we can't double count anything, so you have to subtract it out once. Now, it's also possible that events A and B are mutually exclusive, meaning they have no overlap. So it looks something like this, which means you just add up the separate probabilities. So once again, or means to add, and you just need to watch out for overlapping events or overlapping outcomes, because you will need to subtract that out to avoid the double counting. So let's try this one together. So here you draw one card at random from a standard deck of cards. What is the probability that the card is either a heart or a face card? So I see the word or, so I know I'm going to be adding. So we're going to have to find the probability that you pull a heart, and we're going to add it to the probability that you pull a face card. Remember, face cards are just Jack, Queen, and King. But then it's very possible to have a heart that is also a face card, which means we need to subtract the probability of a heart face card being pulled, because those cards are being counted twice. So the probability of pulling a heart is 13 out of 52. The probability of pulling a face card, well, there are 3 face cards per suit and 4 suits, so multiply gives you 12 favorable outcomes out of 52 possible outcomes. And now we have to subtract the things that are being double counted. So there are 3 heart face cards, the Jack of Hearts, Queen of Hearts, and King of Hearts. So those have been counted here as a heart and here as a face card. So that's why we have to subtract them out. So from here, we can just say that it's 22 out of 52, or you can do a decimal approximation. And that decimal approximation would be approximately 0.423. So either one is fine. And this shows that, okay, you have a little bit less than half the time where this will happen. Okay, go ahead and pause the video and give this one a try. Okay, so here once again there is some overlap in the probability. So the probability of finding an ace is this, probability of spade, and there is one overlap, the ace of spades, so you have to subtract that out. So you should get either 4 over 13 or approximately 0.308. Either way is fine. Okay, now let's talk about the probability of independent events, and this is the probability that event A and event B will occur. So essentially, anytime you see the word and, you're going to be multiplying the two probabilities. So essentially, if you're trying to find the probability of A and B occurring, you just find them separately and multiply. This can work for any number of events. It works for 2, but certainly more than 2 events as well. One thing you need to watch out for is the possibility that the outcome of your first event could affect the outcome of your second event. So you may need to adjust your probabilities accordingly. Okay, so a random number generator selects 3 integers from 1 to 20. What is the probability that all 3 numbers are less than or equal to 5? So we pretty much want to find the probability that the first number it generates is less than or equal to 5, and then that the second number is less than or equal to 5, and same for the third number. Now, these 3 events have no effect on each other. It's a random number generator. So the first number it generates has nothing to do with the second or third. So they're completely independent here. So the probability of the first number being less than or equal to 5 is there's 5 favorable outcomes and 20 possible outcomes. So it's 1 over 4. Well, that's the same exact probability for the second one and for the third one. So now, since it's the probability that all 3, implying the first and the second and the third, we know that we're just going to multiply those three probabilities together, and we get 1 over 64. All right, so go ahead and pause the video and give this one a try. Notice in this one it said numbers less than 12, so 12 is not included, meaning there's only 11 favorable outcomes out of 30, but it's 11 over 30 times 11 over 30. Find the two individual probabilities and multiply them together because it has the word both, implying the first and the second. All right, last but not least, I want to talk about the probability of a complement. So if A is some event, A prime is its complement, and a complement is the probability of event A not happening. So essentially, like, A and A prime should add up to 1. So for example, if there's a 60% probability that something will happen, there's a 40% probability that it won't. If there's a 30% here, there's a 70% here. So they should always add up to 1 or 100% if you're working with percentages. So sometimes it's easier to use the complement to find a probability of something happening. So you can say that the probability of the complement happening is 1 minus the probability of the event, or you can flip these two. The probability of the event happening is 1 minus the complement. So a perfect example is rolling two 6-sided dice, and you want the probability that the sum is bigger than 2. So the probability of event A, we'll just call it event A, is when the sum is greater than 2. Well, there's a ton of different combinations where the sum is bigger than 2. The number of favorable outcomes here is a lot. You would have to go through and count all of those favorable outcomes. However, it's much faster for us to find the complement when the sum is less than or equal to 2. And we know that there's actually only one case when that's happening. So the number of favorable outcomes, or the probability of the event A prime happening, is 1, the only favorable outcome, which is when both die are 1, over 36, the total number of outcomes. So now, instead of having to go and count all of the times when it works for event A, I can just say the probability of event A is 1 minus the probability of the complement. So the probability of A is 1 minus 1 over 36, which is 35 over 36. So this is a really useful tool when you notice that your event, the number of favorable outcomes is really high, which means that the number of favorable outcomes for its complement is really low. So then that might be the way to go. But it's up to you. Just remember, you want to use your time efficiently, so this could be a good option for certain problems. All right, that is all for today's lesson. Thank you for watching.